Welcome to this episode of Cal TV, sponsored by Calvary Robotics, Advancing Automation. I'm really excited to welcome our guest today, friend and titan of the industry, Patrick Sobalvarro, the leader and CEO of the Veo Robotics. And Veo, in a broad overview, and certainly we'll talk a little bit more about that, is using vision and sensing technology to be responsive to human-robot collaboration, certainly a key thing in industry today. And Calvary Robotics and Veo Robotics have partnered together to try to bring this technology to the much-needed environment of manufacturing and other industries. So again, I'd like to welcome Patrick. Patrick, thank you for being on our Cal TV today. And before we get into the depth of what Veo Robotics is and Calvary and our partnership, maybe tell the audience a little bit about yourself and what led you to the development of your company.
Great. Well, Joe, it's so great to be here with you today. Very exciting week for us, being able to announce our partnership with you. And I'm really pleased and excited to look forward to the work we'll do together. My own background is in computer science and robotics, something I occasionally mention, having worked with robots for a long time, is that the first robot I ever programmed was a Unimation Puma 600. So for people who've been in the industry long enough, they will remember that 6-axis robot. In many ways, looks kind of similar to the robots that we all know and love today from whatever manufacturer. In terms of how the company started, quite a long time ago, back in 2008, I had the opportunity to, I was invited to be the president of a new startup called Rethink Robotics. And Rethink Robotics was the first venture-backed startup making a power and force limited collaborative robot. I really believe in talking to customers in the early days, especially, but all along. And I didn't want to make the kind of mistake that you sometimes see a startup make, where somebody wants to invent a technology and then go out to the market and say, well, how would you use this? Rather, I wanted to start by visiting factories, talking to manufacturing engineers, and understanding what the problems out there actually are. So I got the idea for Veo in particular, actually on the BMW final assembly line in Spartanburg, where talking with manufacturing engineers there, they were saying, would the robot you guys are going to build be able to help us with this? Be something like putting a closure like a door or a sunroof on the vehicle, which is being done with a lift assist device. It's got to be done in, they're running a talk time of 73 seconds at that point. And then, that production worker has to turn around and grab the next one and get it into the next vehicle. And I have to say, no, the robot we're making is too small, too weak. Just can't help you there. But I had run a computer vision company before, a company called Intellivid that tracked people around retail stores. Walmart was a customer, for example. And I knew that computer vision technology wasn't reliable enough to use for functional safety at that point. But I thought, gosh, if we could get to a point where we can really reliably do computer vision, then we can work with the robot controls to put the robot into a safe state when somebody approaches it. So it took a while before technology came along to a point where we could do it, but that was the inception of the company.
Wow, that's pretty exciting, but you can see how all the pieces came together over time. And certainly technology has advanced pretty rapidly over the last several years. So two things you mentioned, I didn't realize we had we've known each other a long time, but the connection through Unimation. So for a long time, I actually had a Puma 200 series in my office because I came out of that group, the Soybe group that bought Unimation, et cetera. And I'm from New England, and they were born out of Danbury, Connecticut. And it's funny that today we're discussing this very important topic. And I'm in my office in our Greenville location, which is about 10, 15 miles from the BMW facility. Double connection.
Where you have much better weather than we do.
Yeah. Sorry about that. Anyway, you mentioned in your introduction about the company and expectations. You mentioned collaborative robots, and that's been talked about a lot, quite a bit over the last several years. And in your opinion, is there actually such a thing as a collaborative robot?
I really think that people in the industry really understand that there are no collaborative robots, there are collaborative applications. And that goes for our friends over at Universal Robots, as well as anybody else who really understands functional safety. For example, if you have an application where you've got a power and force limited robot and its payload is unsafe, or there are other hazards in the work cell, maybe a clamping fixture, or you're doing machine tending and you've got a stamping press or something like that, you've got to guard those hazards as well. And the result is that power and force limitation can, in fact, be helpful if you can fit your application into the payload and speed envelopes of those robots. And the payload is not dangerous, and it's a really simple pick and place application or something along that line. But what you can't do is what so many people think you can, which is just take a power and force limited robot and put it into any application, and then it's safe for a human worker to approach it. It simply isn't. And once you do the risk assessment, everybody in our industry knows that you're
and they want to run at full speed on top of it.
Right.
Exactly. Yeah, it's a good point. And as we'll talk more about human robot and collaboration, what that means. And I've often said, you've probably even heard me say, I don't believe there is such a thing as a collaborative robot, collaborative applications. And even if you take a robot that people call collaborative in a very simple sense, and I've said this before, put a feather at the end of that tooling and rub it along your wrist, you'd probably let me do it once or twice. You might even giggle. But if I put a razor blade, I'm quite convinced you wouldn't let me do it once. Yet it's the same robot. So it's really how it's applied. And that kind of leads to some of the other things I'd like to discuss with you. Like, for instance, one of the real advantages that Veo has is what you call FreeMove. It enables greater collaboration between humans and machines. Can you talk a little bit about what FreeMove is and how that does that?
Yeah. So FreeMove 1 is our first product, and we'll be launching that product next month. It's a Category 3 PLD ISO 13849 certified system, and it uses 3D time of flight sensors positioned around the work cell, and you can put them wherever will give you the best coverage. And then the images, the point clouds, the three-dimensional information that comes out of those sensors goes into a computing engine. And that computing engine has a lot of computing power in it, enough so that we can process the information from up to 8 of those 3D sensors, and we can identify, this is a robot, this is a workpiece, this is static background, this is a static hazard, this is the end effector, and other things might be humans, things that are large enough that might be humans that are present in that space. We run a dynamic model of the robot, many different controllers. We support ABB, FANUC, Yaskawa, and KUKA robot controllers. And with that dynamic model of the robot, we can project forward in time and figure out where the robot can get to. So that enables us to do a kind of collaboration that's recognized in ISO 10218, which is speed and separation monitoring. And very capable engineering and systems integration firms like Calvary already have a way of using speed and separation monitoring as a means of providing human-robot interaction, safe human-robot interaction. What we do differently is we can do that dynamically with knowledge of where the robot is right now and where it can get to, so that robot can still be moving at full speed. For example, if it can't get to a place where a human production worker is located before we could safely stop it. So we're always calculating a protective separation distance and a minimum distance to hazard based on the 3D information that we've got in that work cell. And we're always controlling that robot in such a way that we can override the program it's running right now, put it into a safe state, and then when the human withdraws, the robot can automatically resume the operation it's performing. So one of the things, one of the phrases you've used before is that this kind of technology reduces the total cost and complexity of human-robot interaction. Doing human-robot interaction without a technology like this means doing a lot of sequencing in your PLC, trying to figure out distances and where the robot is. You end up with a more brittle way of doing it. You know, for example, if you have light curtains and area scanners, you might not be able to tell where a human actually is or whether that's an obstruction in the work cell. And then you can't reconfigure.
Sorry, I think that's a really important point, because people might say that, well, the robot always knew where the robot was. I mean, as you know, I spent most of my career robot manufacturer, so we knew where the robot was, but not necessarily in relationship to that space being violated. And one of the things that I know you've heard me say, that part of what you're doing is kind of the holy grail, because it's not just even the robot, and it's not just even the end effector, but it's also what it's carrying in addition. So maybe that talking about that, what types of specific applications of the Veo FreeMove powered work cell, what kind of applications do you envision this in?
Yeah, you know, they span a set of what we call application patterns. They're really use cases. One cell that we're putting together right now for a tier 1 automotive components manufacturer is effectively an operator load station. You've got a large plastic closure, and plastic closures for vehicles are actually a great advance in terms of increasing the energy efficiency of vehicles, not having a big sheet of steel on the back of a car that just adds weight and isn't actually a load-bearing member. Much better to have a plastic closure over for your trunk lid, for example, or for your hood.
Right.
But you know, when plastic comes out of an injection molder, it can be flexible. It's large. It can be difficult to load into a fixture, and you've got to prepare that piece of plastic for receiving primer, for example. So you've got to place that in a fixture, and then the robot can easily execute a program where it's preparing it for receiving primer. It can paint it. It can do whatever you need to do. And robots are just so much better at things like that, dispensing adhesive, priming, and so on. All those jobs are difficult for production workers. But if you had to automate the fixturing of something like that, that would cost you a tremendous amount. And with mass customization, you might have different size parts. So an operator load station, very common pattern in manufacturing, but one that has traditionally been set up with a giant rotary table and a sliding door that goes up and down. With FreeMove, you just set up the cell with the sensors, and then that worker can go right in there and fixture that, and the robot will slow or stop as necessary. Worker can go to get the next part while the robot is performing the process step. So operator load station is one case, machine tending, even collaborative palletizing.
So with this technology, you not only give them the advantage of reducing floor space as required, but also potentially throughput, because you don't have to have that second process. You have to wait for the rotation of the device, as you mentioned, to put the next one in the fixture and then fixture it positionally. So it can be done in real time. Thanks for sharing that with us, and giving the audience a sense of where it might be able to use. So now maybe can you tell our listeners that might not be as familiar with this types of technology, what's needed from a software and hardware side to provide a solution that we'll work together on?
One of the things, we're a venture-backed startup, so our investors include some investors out of Europe, like Alpha Intelligence Capital, investors out of Silicon Valley, like Google Ventures and Lux Capital, investors from Japan. We even have an investor from China. And one of the things that the venture industry, I think, hadn't understood initially about manufacturing automation and industrial automation technology is how extremely conscientious the culture is about safety. The popular impression is that robots are very dangerous and so on. But if you go to OSHA.gov and you look up incidents, there are 40 odd accidents since 1984 and 14 or 15 fatalities, which is way too many, absolutely too many. But compare that to motor vehicles, 30,000 people killed a year with motor vehicles, and you got 13 million people going to work in a factory every day in the United States and hundreds of thousands of robots. So what we became aware of quite early on is we absolutely have to build a system that is really, really safe. And I often say to people here, we would rather not have a company than build something that isn't safe. So making sure that our investors, we chose investors who would understand that, and we're very lucky to have very good investors who have that kind of deep technology experience. But when you go to put together that software and hardware, the approaches you've got to take to make something that's really safe, it's very different from making a social media app. There's document control, there's traceability, there's verification and validation. You've got to write your requirements way up front. These systems are going to be out in the field. They already are out in the field, and you don't have an opportunity to, change them overnight or something like that. Functional safety certification. You're counting potential failures in say 1 billion hours of operation, and so you've got to really do it right. And so the approach that we've taken is building a system that is dual channel throughout. So if you look at one of our sensors, and I should have brought one to put on the screen here, what you see is a big window in the center and 2 little windows on the side. And what we're doing is we're pulling that information in, and then in a safety rated FPGA in the center, we compare pixel by pixel. Is everything exactly right in this sensor? Additionally, in our engine, we've got, as I mentioned, a lot of computing power. Well, there are 5 separate computers inside there. There are 2 motherboards with very powerful Xeon processors on them. They're each running that system. There are 2 processors on each motherboard. Each one of those motherboards is running our system in parallel. And then we have a separate safety processor that we built with a Hercules processor on it, safety rated processor, that's comparing the outputs of those 2 independent paths of computation to make sure that they match perfectly and that there haven't been any failures in either system. So that kind of approach and really building a culture that in engineering is completely devoted to safety, I think is one of the key differentiators for us.
And certainly, as you mentioned, the redundancy is certainly, we want to protect people in these environments, and having that redundancy is a protection. So I'm assuming there must have been some very rigorous testing and that you've gone through, and certainly can explore that with us if you'd like. And then maybe a little bit, how is that a little bit different than what was in the market previously that people used, and how this differentiates?
Yeah, I'll mention the testing first. Actually this week, we've been through final testing with our auditor. It all went smoothly, and we're very excited about that. We'll be able to do an announcement as soon as some documents are turned of our safety certification. We built our testing and compliance team by drawing from the medical device industry. That's one of the things that the Boston area has a lot of. We've got a lot of medical device people, and medical devices are an interesting parallel, actually, to manufacturing automation devices in that, there are actuators, there are sensors, there's a very strong regulatory environment. And so that's how we've gone about it, and just the sheer amount of testing is tremendous, but it's got to be built in before that in terms of the requirements being clear, the traceability, and so on. To differentiate what we do from the legacy technology, which through the ingenuity of integrators and manufacturing engineers has been pushed very, very far. Let's take a standard setup for a work cell on a manufacturing line. You've got a process step where you need some human-robot interaction. So you put up a light curtain, and somebody goes through the light curtain, and you issue a Category 1 stop, and you stop the robot or you stop other machinery, and you remove power to any actuators, and you shut down clamping devices and so on. The difficulty once you go inside that light curtain is nothing in the cell knows where you are. So that's why you've got to stop all that stuff. It's like an e-stop. And so resuming from that kind of stop, that gets complicated. If it was a Cat 0 stop, everything is powered off and you got to push some buttons on that robot controller to get it restarted. If it was a Category 1 stop, you've still got to be able to figure out there's nobody else in the work cell, so now it's safe to resume. We can do all of that stuff automatically, and we can do it, especially with robots, with a much more optimal process, because we can tell where the person is, so you can actually be in that cell while that robot is operating, and that cuts down on your talk time. Otherwise, as soon as somebody goes through that light curtain, everything's got to be turned off. And what we want is that fluid human-machine interaction, so that you can have an efficient process, and the production worker can have confidence that it's fine to go into that work cell and fix a missed pick, for example. And you don't have to go find the person with the key to the work cell while the line is stopped and so on. It's a safe interaction.
So again, as you said, not only is it giving the safety, but it's also helping with the efficiency, the throughput, the whole process. So it's more overall for the plant efficiency, brings a benefit. So now let's just maybe touch a little bit on providing a kind of a high level overview, maybe of the partnership between Veo and Calvary, and what are the core benefits of joining forces to the market?
So I think everybody in our industry knows just how much manufacturers depend on the cream of the crop systems integrators. And, the responsibilities of a systems integrator may be, they may go from integrating an individual work cell and doing the design and bringing together the componentry for that, all the way up to, building an entire line for an entire application. And so, you go into a factory of any scale, and always you find manufacturing engineers who are depending on their close relationships with an experienced and capable systems integrator who brings the domain expertise as well as the engineering capability to design a cell, integrate, deploy, commission, as well as support. And so we knew from the beginning that our expertise is not in doing that kind of design and integration and support. And we're a relatively small company. We'll be at around 70 people, mostly in engineering. We're a product company, and our product is FreeMove. So we knew quite early on that we were going to have to work together with very capable systems integrators in a certified integrator program. And it was, something we're tremendously grateful for, that we get to start with Calvary which has such a superb reputation and scale and reach and expertise. So from our point of view, this is a really key step for our company, and we can work together on ensuring customer success.
And you touched on something I think really important too. As you mentioned, we are a RIA, Robotics Industry Association certified integrator. So we are responsible for that risk assessment, evaluating, understanding, and protecting together, your company and ours together, to make sure that the end customer, end user is safe in that environment. So it is a critical part of that in that relationship. So I'm a little bit curious, are industries, core industries you think that this product, this strategy aligns with, or is it really broad across every single industry?
One thing that Boston is kind of a robotics cluster for the United States. Of course, there's robotics expertise all over the world, but in the United States, in terms of new companies doing robotics, the Boston area has a long history. My co-founder, Clara, was one of the people who designed the Roomba, little vacuum cleaning robot. I think everybody's seen the videos of Atlas from Boston Dynamics, another area company. But what you see a lot around Boston is companies that cater to e-commerce distribution. We're a little bit different in that we focused on manufacturing, and that varies. In some cases, it's consumer packaged goods. In some cases, it's automotive. About a third of our customers are automotive customers, either OEMs or tier ones, but also major appliances. One interesting thing I learned working with major appliance makers, so you've got a process there that has just as much customization involved, just as much product variability, and it's a shorter process, about 125 process steps in final assembly for a dishwasher versus maybe 400 in the case of final assembly for an automobile. We've really concentrated first on durable goods and to some extent on CPG. In CPG, one of the things that we have been drawn into a lot is collaborative palletizing, because people have seen the benefit of using a power and force limited robot for palletizing, because with palletizing applications, you get a mispick, you get a crushed case, you get a misapplied label. You've got a problem when your product gets to the customer. They may refuse the load, for example. You have to have a way for people to get into that cell and correct any faults that are occurring along the way. Unfortunately, if you build your palletizing operation around power and force limited robots, you've got limitations of reach, and you've got limitations of payload. So, if you've got a flat pack of gallons of detergent, laundry detergent, you aren't picking that up with no power and force limited robot, right? You need a palletizing robot from one of the major industrial robotics providers. And so we enable that. And so CPG is a place that's very interested in that. But, a lot of parts presentation, a lot of operator load stations, machine tending, a lot of that is already something where in durable goods, you just know you have to have that human present. And so we see a lot of applications in that domain.
So thinking going forward, because what you mentioned, those industries, they're global industries. In fact, those opportunities would present themselves around the world. So, and I know you've talked about, so what's next type of thing for Veo in terms of maybe plant-wide management of, but what about the expansion strategies? Because this certainly has scalability across the world. So how does Veo, have you and your team and your investors looked at what that might look like, expanding the organization to be able to bring this across the world?
Yeah, so our customers right now are mostly in the Americas, mostly in North America. So the United States, Canada, we have a customer down in Argentina. We would expect a lot of operations in Mexico. And our initial certification to ISO 13849 is North American certification. It's not from an EU notified body. We expect to receive EU notified body certification by the end of this year. And that in turn, we do have European customers in Germany, France, and Spain. But right now they can only use the product in an uncertified form, so they have to use redundant safety systems. And they're using it to develop the process steps that will allow them to quickly deploy in production once we receive that notified body certification in Europe. So we think that the Americas are first. Europe will be expanding in Europe, especially upon receiving that notified body certification. Japan is another domain where we would expect to see some good pickup, and we have some great relationships, of course, with Japanese manufacturers and robot makers. So we do, we often joke about how we're a very small global company, and so we've sought to get investment from the geographies where we expect to be selling and deploying our product.
And I certainly understand it. It's part of my history, and like the Robo Coaster was a product that we globalized, and there were certainly different governing bodies across the world. China had their, their regulations, and as you say, some parts of Asia, Europe, and North America. So I understand the challenges there, and where it sounds encouraging. Wish you success, and we'll do everything we can to help you there. So maybe the last question, and maybe important to many of the listeners, I hope, is they're excited about what they hear, and they want to reach out to Veo. They want to reach out to Patrick. What's the easiest way for them to get in touch with you or get an introduction to you or your company?
Certainly, of course, LinkedIn works, and our website at veobot.com, veobot.com. There's a place to contact sales. If somebody wants to contact me personally, I'll just go ahead and say my email address, G like George, although it's Gregory, S like Sam at veobot.com. And we're really delighted to hear from anybody with a need or anybody in the industry who'd like to make contact.
Thank you. And Patrick, we're really excited about this relationship, this partnership. We know that we've found that holy grail to bring to the market together to help many, many manufacturers. And I want to thank you on behalf of Calvary and myself to spend some time with us today. For our listeners, I'm sure there was a great educational opportunity for them, and we look forward to hearing more about the developments of your company. Thank you again for spending time with us today.
Thanks so much, Joe. Always great to speak with you.
Thank you. And for our listeners, again, please reach out to Patrick and Veo if you want some more information. And again, this is sponsored by Calvary Robotics, Advancing Automation. And my name is Joe Gemma. Feel free to reach out to me too. Be happy to help anyone in any time. Thank you both.